Hey guys, this is Aheed speaking, and we are Group 65, and we are here to present our water filtration system. Our main goal was to create a filter that can produce clean, drinkable water. We tried to accomplish this by layering different mesh-sized mediums. The diagram on the right represents our original idea, which I will go into more detail on the next slide. Another goal was to utilize recyclable and reusable materials, such as a water bottle, a reusable housing tube, and washable mediums. We also aim to make the filtration system compact and portable. The housing tube can be detached from the water bottle, making it more compact and easier to carry around. The top layer of the filter was cotton balls. We thought this would slow down the water rate and absorb the dye. It did absorb the dye, however, it essentially stopped the water rate, so we had to add more water. The next layer was small aluminum oxide, which seeped through all the other mediums, causing the water to turn black. After the layer of small aluminum oxide, we had a layer of activated charcoal, which we expected to absorb the chemicals in the water. We then had a layer of medium aluminum oxide and coarse sand. We hoped they would slow down the water and help take some dye out of it. We used cheesecloth at the bottom of the housing tube to prevent the mediums from getting into the water. Next is Ian to present the improvements we made in the next iterations.
Hi, this is Ian. As you saw from the previous slide, the original design was a complete failure, but we knew how to improve it. We removed the cotton balls and small aluminum oxide. We added cheesecloth to the top of the filter and in between layers of mediums to prevent them from mixing together and floating in the housing when dye water was poured in. As you can see from the pictures, the filter water was cleaner. However, it still has some red-black tint, so we sought to make it better. To make it better, we thoroughly washed the activated charcoal. We also added a cone-shaped filter paper at the top of the housing filled with the medium aluminum oxide to slow the dye water rate down as it entered the layer of activated charcoal, which takes out the dye from the water. Due to the background research, we figured out activated charcoal is the best medium to remove dye because of its large surface layer and its molecular structure. Then that was it. Well, our filter was pretty successful.
Hello, I'm Anaka. In order to understand how successful our filters were, we created a spectrophotometer using our Arduino kit. We tested known concentration values to see how absorption was related to dye concentration, and then used this data to determine how successful our filters were. One thing to note is that although some of the absorption values are negative, this is due to how clear water refracts light. Our first filter had an absorption of 0.333, which, based on our data, gave us a dye concentration of about 146%. As we mentioned earlier, this first filter darkened the water more than it cleaned it, which is reflected in the high concentration value. Our second filter was more successful. Our spectrophotometer put the dye concentration at about 35%. Our third filter was certainly the most successful. Our spectrophotometer put its concentration in the negative. One factor contributing to this impossible negative value is, of course, the inherent error in our spectrophotometer and in our approximated relationship between concentration and light absorption. Another contributing factor is that our filter was not completely dry for our Filter 3 test, and the results may have been skewed due to the extra presence of pure water. This is a graph displaying the data we gathered. The blue points represent the data collected by testing the known values of dye concentration. The blue dotted line is the calibration curve we approximated from this data and used to determine the concentration of dye during our trials of our different filters.
Hello, my name is Brittany, and this is the expense breakdown of our final water filter. So we were going for a more affordable water filter, but we ended up with one that is probably more average within the class, which is fine. And our most expensive piece was our housing pipe, which is $70. And one improvement we could have made to that was creating our own housing pipe using the 3D printing, which would have probably lowered the cost by like $40 to $30. So 3 quick future design improvements we would consider is adding a spigot to the clean water tank to make the clean water more accessible, stabilize the base, widen the bottom, and have a tube that can attach to any water ball so anyone can use it. And this concludes our presentation. Thank you.